Hi, friends. This is John. Welcome to our webinar about how to manage nutrition at critical points of influence. This webinar will be about the 5 biggest critical points of influence that determine yield and quality, and which nutrients need to be managed at these critical points of influence, and the different types of impacts that they can have on crop expression. When we think about critical points of influence, I first coined this term and started speaking about these critical points probably a decade ago. And the idea of a critical point of influence is that there is a narrow window of time when the plant is undergoing a significant hormonal shift at different locations, specific locations on the plant, or there is something going on from a reproductive or a growth perspective that has a significant influence on future yield and quality. So there are a number of different critical points of influence for different varieties of crops. We obviously have perennials and annuals. We have what we think of as multi-fruiting crops, crops which blossom and pollinate over an extended period of time, such as tomatoes or cucumbers or soybeans. And then we have what we think of as single fruiting crops, where all the blossoming and pollination happens in a very condensed time window, such as tree fruit. And so you have these different points that occur in different ways on different plants. But in general, these points are universal across all plants, at least across all reproductive plants. So if you have blossoming and pollination, that's a critical point of influence that happens, and the same physiological processes or similar physiological processes, similar hormonal processes happen in a tomato plant as occur in an apple tree. So the profile and the interactions are similar, but obviously they occur in a different sequence. So with apples, blossoming and pollination is the first thing that happens after dormancy break in the spring. With tomatoes, it doesn't happen until after 10 weeks of vegetative growth. So these critical points of influence occur in a different sequence for different crops, but the same foundational processes and principles apply regardless of which sequence they occur in. So the idea is that as the plant grows and develops, there's this constant expansion, contraction energy going on. There's this constant shift between vegetative dominance and reproductive dominance. And we could have a conversation about what this means from a hormonal profile perspective, cytokinins versus auxins. Generally, when you have a reproductive dominant plant, you have a cytokinin dominant plant, which means you have a dominant root system and more growing root tips than you have growing shoot tips. I've discussed this in the past in the webinars. The short version is simply to say that the healthiest plants that produce the highest yields and are the most pest resistant are plants which have a larger root biomass than above ground biomass. And in the case of perennial trees and so forth, specifically what we're speaking about is leaves. So we need more growing shoot tips more growing root tips and more roots that were produced this year from a root flush than leaves coming from the vegetative flush. So there's this constant balancing action and interaction occurring between cytokinins and auxins, reproduction and vegetation, and reproductive nutrients and vegetative nutrients. So what we want to get into in this webinar is specifically what are the 5 major critical points of influence that have the biggest impact on yield and quality for most crops, and what are the specific nutrients that we need to manage at each of those stages, and what are the benefits that we can expect from managing them well at each of those stages. So I wanted to share an example of a corn crop, what a corn plant looks like. So these are the various critical points of influence when a corn plant switches from vegetative to reproductive, and then back to vegetative again, and then back to reproductive. I wanted to share this just as an example of the many different switches that occur as the plant shifts from vegetative to reproductive, back and forth throughout the growing season. The corn plant actually has 13 of these different critical points of influence. And as I described a moment ago, of course, these shifts occur in a different sequence, in a different series for different crops and different plants. Some plants might only have one or two shifts, um, and some might have as many as 15 or 16. It really depends on um, each individual plant's growth factor and the way that it was developed and what it's natively adapted for. So during this webinar, I'll be focusing on these 5 major critical points: bud initiation, bloom or blossoming and pollination, cell division, fruit fill, and ripening. So I'm going to be focusing on these 5 pieces, these 5 sections. First, we start off with bud initiation. So in bud initiation, the pieces that we can influence, what are the changes and the differences that we can make on a crop when we manage this particular critical point of influence well? The first is that we can influence the number of buds. So you can, when the plant has proper nutrition, well-balanced nutrition, you can significantly increase the number of buds that are initiated, or in the case of some plants that are converted from vegetative to reproductive buds, you can increase the number of reproductive buds that you have on a crop. For some crops, this may not be desirable, and other crops, it's very important. The second factor that we can influence at this stage is bud uniformity. If we hope to have a condensed harvest window in the future, if we're machine harvesting a crop, or we want to have a high degree of fruit uniformity, then that needs to begin with a high degree of bud uniformity. The healthier a plant becomes, the more robust and vigorous it becomes, the more uniform the buds become, to the point where there is almost no difference between the primary blossom and the secondary blossoms. So if you're speaking about tree fruit, this might be the king or the crown blossom, and then the secondary and sometimes tertiary blossoms around it. With blueberries, we have this distribution of buds all the way along a stem. The ultimate goal is to have from a health and performance, overall yield and performance perspective, is to have all of those buds be the same size, have a high degree of uniformity, and open and blossom and pollinate at the same time. And that means the fruit will all ripen and mature at almost exactly the same time in a very condensed harvest window. The third factor that we can influence is overall bud size and energy. And of course, it almost goes without saying that bud size and energy translates to future fruit size, and in the case of some crops, also the number of fruit per bud, in the case of cherries, for example. And the next factor that we can influence at this stage is blossom size, which also translates to ultimate fruit size. And we can also influence the bloom timing. On some crops, it's desirable to delay timing or delay bloom and have bloom occur a little bit later to avoid any possible frost damage, freeze damage. And for other crops, it's desirable to move it forward and have it occur earlier. Moving it in either direction can be influenced by the quantity and quality and integrity, the balance of nutrition that is available in those buds. I'll be describing exactly how to produce those. So when you look at the overview, the summary of what we just spoke about, reproductive bud initiation, at this critical point of influence, we can impact the number of buds, the uniformity of those buds, the energy and the size of each of those individual buds, and the size of the blossom, and the timing and the uniformity of the bloom. So what nutrients need to be managed at reproductive bud initiation to produce those effects? And I should mention that this reproductive bud initiation, you need to know when this happens for your crop. It obviously occurs at a different stage in the development cycle for different crops. For blueberries, it occurs as they're going into dormancy. For strawberries, it occurs as they're going into dormancy. For corn, it occurs at 4 to 6 weeks after germination. So there's significant variation on when it occurs for different plants. You simply need to know and understand when this point is for your crop, and then manage nutrition very carefully in the 2 to 3 to 4 weeks that lead up to that point to set the stage for a really successful reproductive bud initiation. When we look at which nutrients need to be managed, number one on top of the list is calcium, because of course we know and understand that we need to have an abundant supply of calcium to have strong cell division and produce as many buds and as many embryos per bud as possible. Calcium is also one of those elements that delivers very strong size, but has a synergistic relationship with cytokinin and increases overall reproductive energy, unlike the other vegetative elements. Manganese, of course, is very strongly correlated with cytokinin's activity and with reproductive bud initiation. We very clearly see that when plants have adequate levels of manganese, we get very strong bud count, and it's fairly easy, relatively easy on most crops to significantly increase the number of buds if we so desire, by making sure that plants have an abundance of manganese. And we also need boron. Boron also has a synergistic relationship with cytokinins as well as with calcium, and helps to facilitate the transport of calcium into the furthest buds. So if you have a crop such as, let's say, tomatoes, where you have a cluster of fruit and the furthest flowers are often significantly weaker than the flowers closest to the base, and you have a wide range of bud size and uniformity, boron is one of the elements that helps increase that uniformity and bring those opposite ends of the spectrum closer together the most rapidly, because it really helps to move calcium and other nutrients out to the farthest buds very quickly and very aggressively. Zinc also contributes significantly to size. There's a direct correlation between the quantity of zinc and overall bud size, overall leaf size, and zinc is also very important for all of the spur-bearing trees. So we know that a significant quantity of the sugars that move into the fruit on a fruiting spur, on let's say cherries or apples, is produced by the spur leaves. So that means we need to have the largest spur leaf size possible. And to get large spur leaves, we need to have large vegetative buds as well as reproductive buds in the fall. And that is accomplished by making sure that we have adequate levels of zinc going into those buds in the fall. And copper also becomes very important because copper stored in the bud contributes to the future of pollination strength. If you have a variety or a strain that does not pollinate very well, making sure you have adequate levels of copper in addition to all these other pieces that we've identified usually has a significant impact on that problem, because it increases pollen strength and pollen tube strength. Lastly, for the growers who are not organically certified, a foliar application of urea can have a very significant effect on perennial crops specifically, who are triggering reproductive bud initiation in the fall. The idea is that when we put on a very late application, foliar application of urea, as the plant is already senescing, the urea will be absorbed by the leaves and transported to the buds. The plant is already shutting down, so much of that urea actually gets stored in the bud in the form of urea, not in the form of nitrates or ammonium. This is really significant because in the form of urea has a very high salt index, which increases the freezing resistance and lowers the freezing susceptibility for those buds. And also, of course, gives them those buds a very strong growth energy push the following spring, and they emerge from dormancy very quickly. Seaweed is known to have many positive impacts for reproductive bud initiation, increasing the number of buds, the size, the health, the vigor. It's become so widely known for this benefit and so widely used from so many different growers and companies that it's not even, there's a long list, a long range of benefits that seaweeds provide, including hormonal support, etc. A longer list than is necessary or worthwhile going into in this conversation. So when we look at the list, the critical nutrients to manage in the weeks just prior to reproductive bud initiation is this list of these 7 nutrients: calcium, manganese, boron, zinc, copper, urea, and seaweed. If you are an organic producer and not able to use urea, then ultimately, of course, the goal is to have soils with such abundant microbiology supplying such abundant nitrogen in the form of amino acids to the plant that we don't need to add any nitrogen. And this is a reality for some organic growers, but not for all. Many growers would still benefit from replacing this urea with a foliar application of amino acids. So there are now dry, water-soluble amino acid powders available that can be used for a shot of nitrogen into the bud. The amino acids have a slightly different effect from the urea. They don't contribute to the freezing resistance that the urea does because they don't have the high salt index, but they do still contribute to the uniform bud size and the vigor as they emerge from winter dormancy. So that's still a very valuable addition. The second critical point of influence that we look at is blossoming and pollination. And when we look at what are the factors that we can influence during this critical point of influence, the first, of course, is the number of blossoms that are pollinated. From prior experience that we've had, it's my observation that it's fairly easy to significantly increase the number of and the percentage of blossoms that are pollinated when we have a poor pollinating variety. I haven't yet figured out how to go in the opposite direction and pollinate fewer blossoms, as would be enjoyed by some tree fruit growers. But if you have challenges with, if you have a variety that you're considering discontinuing because it doesn't pollinate well, but everything in all other aspects, it's a great variety, simply try managing nutrition a bit differently at this stage and prior to this stage. And it's been our observation, our experience with, let's say with Regina cherries, for example, that we can triple the number of blossoms that are successfully pollinated and take such a crop from an average producer to an exceptional producer simply by managing the nutrients at this stage very well. We can also influence the earliness and the speed of pollination. And this is a result of increasing pollen and pollen tube strength. We can produce a condensed pollination window. As I spoke earlier about increasing bud uniformity. Once you have strong bud uniformity, you have good pollen and pollen tube strength, you can have all the blossoming and pollination occur for the crop that you'll be actually harvesting in a matter of 24 to 48 hours in the case of some crops. Other crops can have a slightly longer time window. Increasing pollen strength. So the vigor and the vitality that pollen has to remain exposed within a blossom for during inclement weather, let's say, and remain viable for a period of several days until it can be transported to a receptive blossom, and then also correlated to pollen tube strength. When we have stress during the blossoming and bloom period from, let's say, exceptionally warm, surprise warm temperatures, or very low humidity, there's different environmental factors that can contribute to pollen tubes collapsing. And we sometimes have poor pollination as a result of weak pollen tubes. It's very possible to increase those pollen tube strength and eliminate that problem, which is, I think, one of the big things, the big factors that is changing on the plants and the varieties that we're able to increase the pollination on. So the factors that we can influence: number of blossoms, a percentage pollinated, the speed and the earliness of pollination, and condense the pollination window and increase the pollen strength and the pollen tube strength. The nutrients that need to be managed to accomplish those pieces are first calcium for reasons of cell membrane integrity and overall strength. Manganese, again, there's actually a significant overlap between some of these. Boron also shows up again. Zinc shows up again. Copper shows up this time. Copper did not show up last time. Copper specifically is the nutrient that gives us pollen strength and pollen tube strength and gives them a lot of resilience in challenging climatic conditions. Seaweed shows up again. This is an obvious one. So managing these nutrients at for this stage of this critical point of influence, you can foliar apply these nutrients. If you haven't managed these in the past, you can foliar apply these nutrients starting 2 weeks before we reach the blossoming and pollination window, or in the case of tree fruit, starting right at bud break. You can put on these foliar applications and produce a significant response. You will, however, produce a much bigger response if you apply them proactively and make sure that the plant has an adequate or generous supply 3 to 4 weeks before you get to the blossoming and pollination period. In the case of perennial crops, it's very valuable to make sure that the tree or bush or plant has an abundant supply of these nutrients in the fall before they go into dormancy. And that way we can be sure that they will all be present in the bud in generous supply. The third critical point of influence is cell division. So cell division is when, after blossoming and pollination, we have the embryo, all the cells dividing within the embryo. For some fruit, for many different crops, this period lasts for about 10 to 14 days. Some crops, such as apples, are longer and may extend for as much as 4 to 6 weeks, depending on environmental conditions and climatic conditions. The goal here is to produce, if our objective for the market is to produce as large a fruit or grain as possible, or as heavy a fruit and grain as possible, we want to achieve as much cell division as possible in this cell division window. So when we look at the factors that we can influence, the key factor, the foundational factor, and really the only factor that we care about at this point is producing as rapid cell division and as many cells as possible. This will contribute to a larger fruit, a firmer fruit, a heavier fruit, resistance to bruising, higher test weight. Many of the quality parameters that we are compensated for as growers that we really care about are based on increasing the quantity of cells formed during the cell division period. So the critical nutrients needed that need to be managed during the cell division period, number one on top of the list is manganese. We need to make sure that plants have an abundant level of manganese, not because of what manganese does inside the fruit necessarily, or inside the developing embryo, but because it limits the transfer of excessive potassium into the embryo, which excessive potassium will limit the number of cells being formed because it limits the quantity of calcium moving in. So managing manganese at this stage is one of the most important nutrients that can be managed. And secondly, to that, managed potassium. It's a really bad idea to put potassium applications onto any crop, in my opinion, before the cell division stage is completed. You want to wait until after cell division is completed and you get to the grain field or fruit field period, and then supply your potassium. This will be how you get the largest, heaviest crop that your plants are capable of producing, is limiting potassium early and waiting for the potassium application until you get to the fruit field period. Because putting it on early, as I described a moment ago and I've described many times in other conversations, limits calcium flow into the fruit, and all of our calcium-related physiological disorders, blossom end rot, sidewall rot, bitter pit, corking, etc., all of these calcium-related physiological disorders in the fruit, in many cases, are not a result of inadequate calcium. If they were, the abundant quantities of calcium that many growers apply would be successful in fixing the problem, but they're not. The reason they're not is because the problem fundamentally isn't a challenge of inadequate calcium. It's a challenge of excessive potassium that is preventing the calcium from moving into the embryo. So we need to actually limit our potassium applications until we get past the cell division stage. Then the nutrient that we do need to supply at the cell division stage, of course, is calcium, because calcium, what we have happening in the cell division stage in this developing embryo is we start with a single fertilized cell that divides into two which then divides into 4, which then divides into 8 and 16 and 32 and 64 and 128 and 256 and so on. So you get this geometric progression in the number of cells that are produced inside the embryo. Each of those new cells requires calcium to form the cell membrane. One of the big limitations to the quantity of calcium that can be produced during the cell division window is the quantity of calcium that is present. So obviously, as I described a moment ago, we need to limit potassium and then supply abundant calcium during the cell division stage to produce as many cells and have the material to build as many cell membranes as possible. And then again, boron shows up because of its ability to synergize with calcium and help move calcium into the embryo very rapidly. It's important to have abundant levels of both calcium and boron at this stage of development. So when you look at the critical nutrients, manganese, managed potassium, limited potassium, calcium, and boron at this critical point of influence to achieve a large number of cells, which leads to large, firm fruit that have all the quality characteristics that we're looking for. Then we go to the fourth critical point of influence, which is fruit fill and the fruit fill period. Now, interestingly enough, fruit fill is actually a vegetative stage rather than a reproductive stage because the fruit is expanding and growing in size. So this is following the cell division period. We now switch from cell division to cell expansion. And I've been in this conversation so far, I've been speaking about making reference to different crops, speaking about perennials and tree fruit and berries and so forth. But the reality is these principles and these nutrients that need to be managed are, from what we've observed and worked with so far on 48 different crops that we have in-depth data for, are identical across all crops. The nutrients that are needed at these critical points of influence are the same for wheat and corn and cotton and blueberries and strawberries and grapes and tomatoes. And you can name almost any crop that is grown on a significant commercial scale. The same principles apply. So I'm really having this conversation from a place of foundational principles rather than doing something that is crop specific. Just because I'm talking about tomatoes or corn doesn't mean that it doesn't apply to stone fruit and peaches and nectarines, and vice versa. The same principles apply across the board to all crops. So when we think about fruit fill or grain fill, we're now switching from cell division to cell expansion. And what are the factors, what are the growth characteristics, the fruit or grain characteristics that we can influence at this stage? First, we can influence the quantity of sugars, carbohydrates, photosynthates that are transported from the leaves to the fruit and to the grain. We can also influence the quantity of photosynthates and sugars that are actually produced in the leaves. So that gives us two significant influencing factors. We can increase the quantity of sugars produced and the proportion that is moved into the fruit. This, of course, translates to that we can directly influence fruit and grain quality parameters. So if we're thinking about test weight, protein content, oil content, aroma, flavor, color, heaviness, storability, shippability, sensitivity to bruising, firmness, all of these characteristics are influenced significantly during this fruit fill or grain fill period. And the way that we manage nutrition at this stage is going to determine the quality of the crop that we actually harvest. So when we look at fruit fill, what are the three factors that we can influence? Quantity of sugar produced, quantity of sugar transported, and then the quality parameters of the fruit itself. What are the specific nutrients that need to be managed during the fruit fill or grain fill period? First is potassium. Any crop which produces a large amount of carbohydrates and stores a lot of carbohydrates in the fruit or in the seed, all of those carbohydrates are transported into the fruit or grain by potassium. There's a direct correlation between the presence and availability and supply of potassium and the quantity of sugars that can be transported. So if we want to have very well filled and very full, very plump kernels on our nuts, or larger sized fruit, larger sized berries, high test weight grain, we need to have an abundance of potassium to be able to transport those sugars into the fruit or grain. Nitrogen is an obvious one. You'll notice this is the only place, with the exception of the urea or amino acid application during reproductive bud initiation, this is the only place where nitrogen shows up as being critical to influence the quality and quantity of yield. Manganese shows up again. Manganese, but the presence of manganese and also the presence of zinc and the presence of boron within the seed, within the fruit, all have an associated relationship with auxin synthesis. So as the seed and the fruit begins maturing, it begins producing auxin. And the quantity of auxin that it produces is correlated to the presence of these trace mineral metals and boron in the seed or in the grain. And this is very important because the hormone auxin is the master control switch that controls where sugar goes inside the plant. So a simple way of saying it is to say that the more of these trace minerals we have in the fruit or in the seed, the more auxins are produced, the more sugars will be attracted to that fruit. So if you want to have a very sweet fruit and move a lot of sugars into the fruit, that means we need to have very good auxin synthesis, which means we need to have abundant levels of these trace minerals, manganese, zinc, and boron that I just spoke about. Again, calcium shows up, and it's worth mentioning it's been reported in the literature that the majority of calcium that is present in a mature fruit will move into the embryo during the cell division period, the first 10 to 14 days after pollination, or the first 3 to 4 weeks after pollination. And I believe that that is often the case. It's generally true, but it's not necessarily true, and it's certainly not the case for a really healthy plant. And we've observed this. We've worked with growers who have measured it. When crops have an adequate supply of calcium, and calcium, by the way, needs to come from the root system in order for the tree to be really healthy. We can band-aid it with foliar applications, but the really healthy plants have a constant supply of calcium coming from the root system, being transported to the fruit, the upper parts of the plant every single day, every 24 hours, because calcium is not transported in the phloem. It can't move from the leaves into the fruit. And so when you apply calcium chloride to the leaf, it doesn't move out of the leaf into the fruit. In order for calcium to move out of the leaves and into the fruit, it has to be in a chelated form. Ultimately, we need to get calcium coming from the root system upward. And there's a lot of evidence that suggests that calcium moves into the fruit throughout the entire fruit field process as long as it is available from the soil. So if we have problems with bitter pit or corking, or all these calcium-related physiological disorders, it's possible to address those during the fruit field period by making sure we have an abundance of calcium coming from the soil profile. It's much easier to fix it that way than it is to fix it with a foliar application. And my reason for this perspective is we have actually measured and have worked with growers who have measured the calcium content in the fruit when mature on apples and other crops. And the quantity of calcium that is present in the mature fruit in a number of cases has been larger and more grams of material than the fruit embryo and the small fruitlet actually was in total size. So there's evidence that calcium does move into the fruit during the cell expansion period, during the fruit field period as well. It needs to come from the soil system, which of course requires good biology, and that's a whole other conversation in and of itself. The other element that is very important to manage during this ripening and filling process is copper. Copper gives us a lot of resistance to many of the different pathogens that might want to infect the skin of the fruit. So cedar apple rust and scab and scurf, and kind of the list goes on and on. When we have adequate copper levels, we have more resistance to those organisms. But more importantly, Copper also gives us very strong stem and skin elasticity. So if we have fruit that might want to snap off easily, having an adequate supply of copper will give us strong stem strength and stem elasticity. And it also gives us strong skin elasticity. So if we have fruit that has a tendency to split, such as grape tomatoes or cherries, when we have an abundance of copper, that gives us skin elasticity and significantly reduces the potential for splitting. So the critical nutrients to manage during this ripening and filling process are potassium, nitrogen, manganese, zinc, boron, calcium, and copper. When we get to this remaining stage of ripening, so ripening is the stage, you noticed I'm distinctly creating a separation between ripening and fruit fill. So for some crops, these two stages are very closely associated. What I'm referring to specifically during the ripening process is when plants begin, for many plants, when they begin senescing. If you take cotton or corn, for example, corn is actually a really good example here. There is a very close connection between the plant senescing naturally, as it should, ripening, and grain fill. Those are closely connected, but grain fill still happens a little bit before the senescence and ripening process. And what we have learned is that we can have a significant influence on the natural senescence and ripening process that has a tremendous impact on quality. So I wanted to break this out and speak to this specifically a little bit. So what are the factors that we can influence during the ripening process? The first, and the one that I'm most impressed by, or very impressed by, is that it is possible to produce a ripe crop on green plants that are just beginning to senesce after the fruit is fully mature and fully ripened. What this means, I've actually had this conversation in the context, in case of corn, I've had this conversation multiple times with Dr. Michael McNeil, who was actually a corn breeder. He describes how in their breeding work in the 60s and 70s, they would actually select for hybrids and for varieties that the grain would be completely dry, 15 to 15.5% moisture content grain, and the stalk and the leaves were still completely green from top to bottom with no leaves that had started senescing. That was their indicator for a really healthy, high quality corn plant. That is true senescence. That's true ripening. That is where you have a corn plant drying down, where the ear itself is dry and the rest of the plant is still green. Michael also has related how many times he's experienced harvesting corn that is 15.5 to 16%, maybe as high as 17% moisture content, and there is juice squirting out of the snapper rolls on the combine. So the plants themselves are still green enough to produce silage, but the grain itself is mature and dry. That is producing a plant with proper dry down and proper senescence. What we see today is we see crops that are not drying down, they're dying down, where nutrients are being tapped out of the older leaves, the top of the plant, of the bottom leaves, the bottom of the plant, and they're moving together into the ear. And the result is a corn plant that has completely dried down, is completely dead, but has 22% moisture content. That's the difference between die down and dry down. The unhealthy plants died down. So the other characteristics that we can influence during the ripening process for fruit crops, vegetable crops, are color, increasing color on grapes, redness, for example, increasing the aroma and the flavor, sweetness, firmness, all these related quality characteristics that we care about. And it's also possible to speed up or to slow down senescence. If we're growing cotton and we want the leaves to drop off very quickly or early, and we want the plant to senesce and open bolls very early, we can speed up senescence with managed nutrients. If we're growing wheat and we want the wheat to dry down very quickly so that we can get earlier to harvest, we can speed up senescence. We can speed up maturity and ripening by a significant amount by as much as 5 to 7 days or more, depending on climatic conditions. So it's possible to speed up senescence. It's also possible to slow it down and have plants remain green for a much longer period of time. And this is all based on how you balance and how you manage some of these trace minerals. So ripening, factors we can influence: green plants, proper senescence, quality characteristics, and speeding up or slowing down senescence based on how we manage nutrition. The critical nutrients that we need to manage during this ripening period to have this effect. The first one is boron. Boron is the sugar translocation engine and switch. Previously, I described that auxin has this characteristic, that auxin determines where the sugar goes and attracts sugars into the fruit, which is the case. Boron speeds up the rate at which sugar moves inside the plant. So if you have a crop that you want to dry down very quickly, let's say wheat or cotton, or something that you want to speed up harvest of and you want the harvest to happen earlier, simply put on a very strong foliar application of boron. And boron will rapidly move the sugars. It'll speed up the movement of sugars out of the fruit or out of the leaves and into the fruit or into the grain. And this is a significant win. It's much better than using desiccants or dry down products, because with a desiccant, you lose all the sugars in the leaves. With a boron application, you actually move all those sugars into the fruit or into the grain, and you actually produce a higher test weight, greater nutrient density grain or fruit as a result of using boron rather than using other desiccants. And this is boron's natural function as a nutrient. You don't have to put on excessive quantities. I'm sure many of you know, if you use boric acid specifically, that specific form, and apply it in extreme concentrations, ridiculously high concentrations, it can actually have an herbicidal effect. That's not what I'm talking about. I'm not talking about using boron as an herbicide, but simply what would be considered a high rate from a nutrition perspective will allow sugars to move very rapidly into the fruit or seed. You can also do this to trigger dormancy on plants that want to grow too late into the season. If you have a mild fall, if you take alfalfa, for example, sometimes alfalfa wants to grow very late in the winter, and we want to knock it down. You can put on a strong foliar application of boron at a rate of upper ends of suggested label rates in the neighborhood of 3 to 4 quarts per acre. And that will rapidly transport the sugars out of the leaves and down into the crown. And the next spring, if you do a treated versus untreated area, the treated area in the fall, it looks brown because it browns down faster. It doesn't stay green. The sugars move down to the crown. But the next spring, there is a significant difference in the speed at which it grows in the spring and the early yields because of that boron application in the fall. You can do this with any perennial crop. You can speed up senescence by supplying adequate or generous levels of boron. You can do the exact opposite with cobalt, because cobalt inhibits the formation of ethylene. And I'm sure many of you are familiar with the many different influences and impacts of ethylene. But what we can say very simply is that when we supply adequate levels of cobalt, we can delay senescence and extend the plant's lifespan. We can have it remain greener longer, and we can keep fruit on the plant for a longer period of time. This becomes a very valuable tool when you are producing, let's say, machine harvested green beans, for example. And if you want to harvest three different pollination sets, 3 sets of beans instead of just 2, when you supply adequate to generous levels of cobalt, it will inhibit the ethylene formation and slow down maturity of the first set of beans so that they don't become too large, and the plant remains green and continues to blossom and bloom and reproduce, and you can actually harvest the first, the second, and the third set all at the same time, and they'll all be high enough quality to ship and to pack. So this is a very useful, very effective tool if we want to slow down maturity and slow down ripening and have it happen over a longer period of time. And then we have 3 additional elements that I've included here: magnesium, sulfur, and molybdenum. Why those 3? Because in many cases, the one nutrient which really messes up proper ripening and proper maturity and senescence is the presence of nitrate. So the reason for including magnesium, sulfur, and molybdenum is not because the plant necessarily needs those three elements, but that those three elements correspond to reducing the presence of nitrate in the plant and allowing the plant to ripen and mature properly. So those five nutrients, those five elements to manage again are boron, cobalt, magnesium, sulfur, molybdenum. Lastly, we've added one to the mix, vegetative growth, because we haven't talked about vegetative growth at this point. We know that all crops go through periods where they have a root flush or a vegetative flush, and the factors that we can influence are we can produce very rapid vegetative growth with tightly spaced internodes, and on perennial crops with what is termed high carbon wood that has a much higher future reproductive potential. So during vegetative growth on both annual or perennial crops, whether it's cotton or soybeans or tomatoes or apples or pears or cherries, we want to have tightly spaced nodes. And it's possible to get those tightly spaced nodes with the same speed and quantity of growth as we get with nitrogen, but without supplying nitrogen. We want to get the same speed and mass of vegetative growth without the presence of nitrates for pest resistance, disease and insect resistance, and for higher quality yields and for higher quality wood. So these are the factors that we can influence during vegetative growth. How do we do that? Which nutrients do we need to manage? Very simply, we need to get vegetative growth energy from calcium instead of from nitrogen. I speak about this at some length on the podcast episode that is titled Managing Reproductive and Vegetative Nutrients. It's too much to get into right now, but very simply, kind of a quick bullet point summary, there are four nutrients which trigger a very strong vegetative growth response in plants. The four nutrients are nitrate, potassium, chloride, and calcium. We don't often think of chloride as being a nutrient, but it is still present, it is absorbed by plants, and it does produce this effect. The first three that I mentioned, nitrate, potassium, and chloride, have a synergistic relationship with auxin, and they give us these very widely spaced nodes, very rapid shoot growth, auxin dominance, very widely spaced nodes because of their synergistic relationship with auxin. Calcium, however, is different. Calcium also produces this very strong vegetative growth response. You get the same speed of vegetative growth and the same mass in the same amount of time, but calcium has a synergistic relationship with cytokinins instead of auxins, which means that it triggers stronger reproductive energy as that vegetative growth is being achieved. The result is that you get nodes that are spaced 2 inches apart instead of 4 inches apart. This means that you get many more bolls on a cotton plant, many more buds, and many more spurs on the different plants. So the healthiest, highest quality plants are always those which are cytokinin dominant, and that's because they get their growth energy from calcium instead of from nitrogen, potassium, and chloride. So again, to the points that I made earlier, we need a constant supply of calcium every 24 hours coming from the root system upward from the soil. We need a supply of boron to synergize with calcium for all the obvious reasons that I described earlier. So these are two critical minerals that we need to manage during vegetative growth. An abundance of calcium and an abundance of boron will resolve a lot of the challenges that we have with poor quality, weak vegetative growth that is disease and insect prone. So if you'd love to learn more and get more of this really in-depth agronomic information, you can sign up on our website, advancingecoag.com. We have an email list. You can find it down at the footer at the bottom of the website. And we send out updates on when we're hosting these webinars and a lot of other information that isn't necessarily on the webinars that we put out there as well. So first question, I grow southern high bush blueberry varieties, and we do not have a dormancy stage. In some cases, we pick for 10 months of the year continuously. How would you suggest identifying the CPI for any stage in the growing cycle? This is a great question, one that I intended to address during the presentation and missed. This is a similar question. The same type of question also holds true if you are growing tomatoes, for example. Any crop where you have a blossoming and pollination period that is present for an extended window and doesn't happen all at once. For these crops, if you review the list that I provided, there's a lot of overlap between the various nutrients that need to be addressed. And this is true for a number of different reasons, but um, the one for these crops which have an extended bloom and blossoming period, simply address all of those nutrients for the entire time window, make sure they have an adequate to general supply of all of them, with one exception. There are, within that context, within these crops, there are two nutrients that you need to manage very carefully. First is you need to manage potassium, because obviously you need enough potassium to fill the fruit and grow a large firm fruit, but not so much potassium that you limit calcium flow into the developing embryos for the new fruit that is just setting and that is just going through cell division. So the key is to supply as much potassium as you need and no more. Excess of potassium is a significant problem, can be a significant problem for these types of crops. The second nutrient to manage really well is manganese, because manganese serves as the potassium thermostat and will prevent the excess of potassium from moving into the embryo. So make sure that you err on the generous side of having a generous supply of manganese. When you manage those two pieces well, plus all the other trace minerals, everything else should flow very well for these continuous fruiting crops. Another question here from Greg Pennyroyal. Hi, Greg. If we want to assure proper nutrient levels for bud initiation, and we know from history that the vines will be deficient in a number of critical nutrients, will foliar applications prior to leafing work, or is fertigation our only options, aside from fall application, which are obviously the best option? Yes, Greg, so obviously fall applications are the best. I believe fertigation is the best option for calcium, and foliar applications are a very good option for all the trace minerals. And actually for calcium as well, as long as calcium is in a chelated form with organic acids or amino acids. There is a significant body of evidence that suggests that perennial plants, berries, trees, etc., can absorb a lot of nutrients through the bark. And so you can do foliar applications at the dormant period and have them absorbed and move into the buds. So this is actually an application that we're doing more and more of. Another question from Jim. Hi, Jim. Jim Pingree. With permanent crops that have a February bloom prior to vegetative growth, we utilize foliar applications of critical nutrients. How important is soil applied at this time? We have already applied post-harvest applications. I was hoping to wait till the first sap analysis in March before applying any micronutrient applications to the soil. So, Jim, in general, I would say that you are on the right track with the right approach. Our goal when we work with growers is to supply a generous supply of nutrients in the fall before dormancy, so that those nutrients in a generous supply, the calcium, boron, zinc, manganese, copper, everything that we talked about, is stored in the buds in a generous supply, and we are not dependent on the spring applications. So if you are successful in supplying good nutrition in the fall, then you don't particularly need spring applications on the bark. Spring applications on the bark, from my perspective, are kind of an emergency band-aid effort that is needed when we weren't successful in building the nutrient levels in the tissue the year before. So when we've been successful in the fall, then I would suggest you don't need to put on those applications in the early spring. You can wait until you get your first sap analysis results back, unless you know that there is more that could still be added that you would benefit from. So in many cases, when we work with growers, the first several years, 2-3 years of developing, particularly with a perennial crop. Perennial crops, trees, are very responsive to foliar applications. I'm amazed at the response that we get. And we do often get responses from early spring applications, even when we've done fall applications the first year or two after we begin making the switch. So hope that was able to answer your question. Question from Mr. Anonymous. Nitrate is a vegetative nutrient and potassium as well. There's also discussion of nitrate limiting the uptake of potassium. How does this work? Another one, what is a good book to read about vegetative reproductive processes in plants? So to your first question, in all the thousands of plant sap analysis reports that we have collected and that we have in our database, there is no evidence of a correlation that potassium inhibits nitrate uptake or vice versa. I know that that is reported in some of the literature, but the database says that that isn't actually the case. To your second question, unfortunately, there isn't a good book that I'm aware of right now on vegetative and reproductive processes in plants. Kerry Reams spoke about this quite a bit, as did Dan Scow. He has his book, Mainline Farming for Century 21, but it's not, there's also a lot of the Reams terminology that is difficult for some people to follow. Kind of the world-renowned leader in this space, I was hoping to interview on the podcast, but in spite of my best efforts, I didn't succeed in getting him before he passed away, was Jerry Stoller. So I will be publishing a lot of work on the blog on hormones, hormonal interactions, and nutrient interactions in the coming months, and try to get some of this information in writing. I think one of the most popular places that I'm aware of to learn more about this is the podcast episode that I did where I spoke about managing vegetative versus reproductive nutrients. Question from Steve Darcy. Hi, Steve. If gypsum is applied prior to cell division in grasses at 100 pounds per acre, will calcium still be sufficient at cell expansion, or would a foliar application of calcium be helpful at that point? So you mentioned specifically in grasses, and unless you're producing grasses for seed, then you don't really have a reproductive period, and you're mostly concerned with cell division. And to answer your question about whether calcium would be helpful at that stage, it really depends on how much calcium your soil already has. And I'm not really able to answer that question. The best way to find out and to know for sure is to pull a sap analysis and identify exactly what's happening and what's going on, and then you will know exactly whether you have enough calcium or whether you need to add more. Jerry Snyder asked the question, at what point would you apply sap analysis to critical points of influence? I would say I would use a sap analysis. Preference, of course, is to use them every 2 weeks of the growing season because that's when you really learn the most. If that is not possible, then collect them 2 weeks before you need to put on, or excuse me, 1 week, 1 week to 10 days before you intend to put on an application. So you can think about when the critical point of influence happens, what stage of development. You want to put on a foliar application a week before that. You pull your sap analysis a week to 10 days before that. That will give you the information to know exactly what to apply in your foliar application to influence that CPI. Question, what sort of forecasting is necessary to shift bloom timing? Is this only possible in fall in anticipation of the following year? Or is there wiggle room if frosts are coming unusually late in the beginning of the season or unusually early near the end? So, as I mentioned when I was speaking about this, it's quite easy to speed up and produce earlier bloom, simply doing all the things that we mentioned that I described will give us stronger buds and blossoms that are more freeze resilient, and they will also have a lot of energy, and they will tend to bloom earlier given the same climatic conditions, or they'll bloom faster. I guess I should say, not necessarily earlier, but faster. They will go from, let's say, pink stage to full bloom much more quickly than plants which are not treated this way and which don't have good nutrition management. So, another question, is there a limit to how often a grower may use boron or cobalt to speed up harvest and initiate harvest early or delay it? The concern is that it may accumulate over time in soil if used regularly, even if used within reasonable quantities, and lead to excessive boron and cobalt for a future crop at some point in the future. Not going to happen, not at all. The application rates that we're talking about, I'm specifically referring to this as a foliar. So the foliar applications of boron and cobalt that are required to produce the response that I'm talking about are just a fraction of what the soil requires. You could do these applications every year for decades, even multiple times per year for decades, and not even begin to approach the level of excess or abundance in the soil profile. It takes just a fraction of the quantity to influence plants as it does to influence soil. Question from Darren Petzer. What are the limitations to cytokinin production? Darren, the answer is quite easy. Anything that limits root development, because cytokinins are produced in growing root tips, and the enzyme cofactor required for cytokinin synthesis is cobalt. So make sure you supply adequate or abundant levels of cobalt and have an environment, a soil environment for very rapid root development, and you'll be able to produce an abundance of cytokinins. Lori Brown asked the question, what root conditions are necessary for good absorption of calcium, potassium, and magnesium? Are root hairs essential? Is root growth essential? Can larger roots not absorb water and its cations? So, Lori, to answer your question well, I would suggest you look at my blog post of yesterday. You can find on johnkempf.com. You can also subscribe. I post a blog post almost every day, 5 to 6 per week. And I referenced Dr. James White's work. I interviewed him recently on a podcast and released that, and we do a deep dive into how plant roots actually absorb nutrients from the soil profile. And it's very different from the way people think. What they actually do is they have the capacity to absorb entire microbes and strip the nutrients from those microbial cells and then release those microbial cells out through the root hairs. So it'll give you a whole new appreciation for how roots actually function in the soil profile. And that would be the place where you'll find the best answer to your question. Question from Murray Hutton. Is gypsum a good source of calcium to use? The answer is yes. From a soil application, we use gypsum a lot as a calcium fertilizer. The key is to apply gypsum in a timing window that gives us the right calcium release during the cell division period. So gypsum, depending on moisture and soil conditions, climatic conditions, begins releasing at about 30 days after application, and the release curves upward dramatically about 45 days after application, and then declines again 90 days after application. So the biggest calcium release happens in the 45 to 90 day window, which means that we want to apply our gypsum 45 to 90 days before the cell division period. This means a fall application is a really great idea on some crops and a really bad idea on others. On some crops, we want a fall application, and others we want a spring application. We really need to time it in correlation to the cell division period. Anthony Granatelli, hi Anthony, asked the question, what types of climatic stress does copper help with and why? So specifically for the fruit that are susceptible to splitting and cracking, copper helps produce resilience to those rainfall events that produce that type of cracking because of the increased elasticity. And then anything that puts, as to the earlier question about wind damage, anything that puts physical damage on the plant. If you walk through a crop, and this is a common experience with brassicas, if you walk through a crop of broccoli or cauliflower or cabbage, it's very common for the stems, the leaf stems, to be very brittle. Or I shouldn't say it's common, but it happens fairly frequently for that crop specifically. You can walk through it and the leaves just break off the plant. That's a signal of inadequate copper. When you have adequate levels of copper, the leaves, the stem, everything about the plant will become a lot more flexible and a lot more resilient to wind damage and hail damage and anything that has the potential to physically impact the plant. And of course, it's also connected to resistance to a lot of different disease and insect organisms as well. Are all these principles the same for producing grass seed and vegetable seed? The answer is yes. Another question, in a microbially robust soil, in your experience, are these intensive management approaches really necessary? So it is possible to produce, the more microbially active and microbially robust your soil becomes, less of an impact these management practices will have because your soil, your overall system will be functioning much better. It is still often possible to gain an additional edge and additional advantage. Question, what is the preferred rate and form of copper in tree fruit to assist elasticity but not cause rust? It needs to be a chelated form of copper, preferably an amino acid or organic acid chelate, such as our rebound copper. Question from Anthony, if you do a foliar bark application during dormancy, do you need to do it in the evening or morning, or does it not matter that time of day it is done because there are no leaves? I don't know for certain, Anthony. But my understanding is that bark absorption happens a bit more slowly, but very consistently, and it's not dependent on the air humidity or moisture. Um, and if that's the case, and that's my present level of understanding, I don't think it'll make a significant difference at what time of the day it's done. Other than I would say that the longer you can keep it liquid on the bark, the better. So if you do it at the time of day when you have the highest humidity, that would probably be optimal. A question from Tim. In our location, we get 40 inches of precipitation and boron tends to wash through our soils. We're deficient in boron on pear and apple tissue analysis. We currently only apply boron foliar at pink and post-harvest. I feel we need more application, but all consultants are very fearful of a boron toxicity. Your thoughts? My thoughts are you serious? Yeah, I'm sure you are serious because we encounter this quite frequently as well. Here's the bottom line. Compare the photos of a boron toxicity and a calcium deficiency. What you will discover is that they are identical, exactly the same thing. So they're really, from what I've observed and experienced, I would suggest there is no such thing as a boron toxicity, only a calcium deficiency. And we've actually had experiences where growers didn't follow instructions and put on boron application rates at 3 to 4 times the recommended application rate due to a misplaced decimal point. And the crop begins showing the yellowing, whitening leaves that are signals of a boron deficiency. We put on a foliar application of a chelated calcium, and 48 hours later, the symptoms are gone. So a boron toxicity is only a calcium deficiency. If you apply calcium and boron together, you will not observe any symptoms of a boron toxicity on almost any crop that I'm aware of, including the crops that are very sensitive to boron, such as green beans. Question from Larry Augustine. What is the value to the soil from the stalks of harvesting, as you described, corn with dry grain, but where the stalk is still very much alive, even to the extreme of sap dripping off the rolls? Can you compare this to harvesting dead corn and the soil health implications? Laron, do you know what I find interesting about your question? What I find interesting is that we think about sap dripping off the shucking rolls as being extreme. And yet, what Michael McNeil has described as being true historically is that that was the status quo and the standard in the 70s. That was normal. And we've forgotten what normal actually is. So what are the soil health implications? I don't know because I haven't experienced and personally observed corn that healthy very often, but I would anticipate, of course, that the crop residue with that high moisture content still has a lot of sugars and everything else would be decomposed much more rapidly. And it's very probable that it would have a bigger contribution to organic matter and building soil organic matter than dead corn, which is some of it is going to be held in the soil, but the majority of it, in many cases, is actually oxidized off and lost into the air as carbon dioxide. Olivier Tessel. Hi, Olivier. Do these CPIs apply for potatoes? Can we use the same nutrients at the same stages for potatoes? And the answer is yes, you can. You're familiar with tuber initiation and the hook stage, and when tuber initiation happens. And then your question, you asked another question, is how can we make calcium sufficient for the potatoes? As I'm sure you know, calcium in potatoes is actually absorbed from the correct name is escaping me at the moment, but from very fine roots that are attached directly to the potato. They don't even connect to the rest of the root system. They attach directly to the potato. So we need to have a strong supply of calcium in direct proximity to the tuber. Our tool for achieving this and accomplishing this has been to apply a fairly strong, very heavy application of gypsum, calcium sulfate, in the furrow at planting to make sure that we have an abundance of calcium in close proximity to the tubers. And that's been our tool for achieving calcium sufficiency. Question from Scott May. If it is best for the plants to get calcium from the roots, from the soil, would microbial inoculation of the roots help? And if so, can you suggest inoculants? Scott, the answer is absolutely yes. I believe microbial inoculation is imperative. It's not even optional. And when you speak with our team or go to our website, you can find the inoculants that we recommend. We recommend those developed by Tiny Technology. We use a lot of their spectrum. There's a few more questions and comments, but I think I've answered most of them in some setting. I'd also invite you, if you want more information like this, you can also subscribe to my blog, johnkempf.com. I want to thank all of you for attending. I hope you have a wonderful day. You find the information useful and valuable, and I hope to speak with all of you again soon. Have a great day. Thanks, everyone. Bye.